Now we'll be looking at the differentiation of explicit algebraic and trigonometrical functions. So we've defined differentiation as the study of rate of change, and I told you to just think of it like the gradient of lines or the gradient function of curves. So commonly it is denoted as dy over dx. And what does it mean? So dy over dx is just a fancy way of differentiating y. So we are differentiating y with respect to x. So that is what dy dx means, differentiating y with respect to x. So how do we go about this? So now we're going to be taking it one step at a time. So first, let's look at the differentiation of a constant. So the differentiation of a constant is 0. So for example, if y is equal to 7, then dy over dx will be equal to 0. Similarly, as you see here, if f of x is equal to 8, so df of x, which I've explained before to be equal to y over dx, is equal to 0. So when you differentiate a number, any number, positive or negative, fraction or integers, always turns out to be what? 0. So the differentiation of a constant is 0. So now, how about the differentiation of y is equal to ax? So if you have an expression in this form, y is equal to ax, and differentiate it, what do you get? So differentiation of y equals to ax dy dx is given as a. So what this means is that when you have a function in which you have a coefficient before x, when you differentiate that function, it results in only that coefficient. So now let's look at this example. We are told to find the derivative of the following functions. So y is equal to x. So what is at the coefficient of x? You can see that the coefficient here will be 1. So we know that dy over dx will be equal to what? Equals to 1. The coefficient here is 1. So let's look at this example. Y is equal to minus 3x. So dy over dx will be equal to what? The coefficient of x here is minus 3. So dy dx will be minus 3. And here we are told that y is equal to 2x over 3. So if I write that out properly, I can also write it as what? 2 over 3x. So what is the coefficient? 2 over 3. So I can write dy over dx to be equal to what? 2 over 3. So when I have a function in terms of a coefficient and x, the differentiation of that function, the derivative of that function will just result in the coefficient of x. So now let's take it one step further and let's talk about the differentiation of y is equal to x raised by n. So this gives us the general formula of differentiation. So when I differentiate y x to the power of n, my dy over dx becomes nx raised to the power n minus 1. So as you can see, n here represents the power of n of x. So I multiply the function by the power which is n in this case, and I raise x to the power of n minus 1. So I reduce the power here by 1. So now let's try to apply this law to find the derivative of these three functions. So in the first one, I'm told that y is equal to x cubed. So as I can see, the value of my n here is equal to what? 3, because the power here is 3. So my dy over dx will be equal to what? According to the law, I write the power down first. So I write 3 down first, then times. I have x, then I have the power, which is what? 3. Then I subtract 1 from it, minus 1. So that becomes what? 3x squared, because 3 minus 1 is 2. Now let's take a look at this example. In this case, my n here is what? Minus 2. So my dy over dx will work out to be, I'll first write out my n, in this case, which is minus 2. Then I have x to the power of minus 2. Then I subtract 1 from the power, minus 1. So that becomes what? Minus 2x raised to the power of minus 3. And finally, for this example, I told that y is equals to 5x raised to the power 5. So dy over dx, so I have a 5 already here. So I have to bring this 5 down, since my n in this case is what? 5. So I bring it down. So I have times 5. Then I have x raised to the power. Then I reduce the power by 1. 5 minus 1 based on that formula. So I have 5 times 5, which gives me 25 times x. Then 5 minus 1 gives me 4. So this is the way we differentiate functions when we have y power of x n. So now let's try to look at some more examples. In this first example, we are told to differentiate y is equals to x to the power minus 3 over 2. And to recap, I'm going to write out the formula out again. So when y is equals to x to the power n, dy over dx is given as nx raised to the power n minus 1. So in this case now, my n is equals to what? My power is minus 3 over 2. So my dy over dx becomes what? My x, my n, I write out my n first, which is minus 3 over 2, then times x raised to the power minus 3 over 2, then I subtract 1 from it based on that formula. So that becomes minus 3 over 2x, and when I subtract these things together, it results in what? Minus 5 over 2. So this is the differentiation of this function. So now in this case now, value of my n is what? My n here is what? 5 over 3. So I can work it out. So my dy dx is equals to, I have a 4, then I multiply it by, I bring my n down, and my n in this case is 5 over 3. Then I have my x raised to the power my n, which is 5 over 3 minus 1. And that works out to be 5 times 4 is what? 20 over 3 times x raised to the power 5 over 3 minus 1 gives me what? Gives me 2 over 3. So this is what it becomes when I differentiate. Now in this last case, my n in this case is what? Minus half. So my dy over dx will be equals to, I have minus 3, then I bring down my n, which is times minus half, then I have x raised to the power minus half, then minus 1. So that becomes minus times minus is plus. So this gives me what? 3 over 2x, then minus 1 over 2 minus 1 gives me minus 3 over 2. So when I differentiate this expression, this is what it results in. So now let's look at the derivative of a sum. So now when we have a function in which we have sum of different terms, how do we differentiate it, or how do we find its derivative? So you just differentiate individual terms in the function and sum them up. Is that straightforward? So what we do is that to find the differentiation of this expression, we differentiate each of these terms individually and we sum them up. So to do that, I'll write it out. So I have dy over dx will be equals to, so this becomes 2 times, then I bring my 3 down based on the formula. So I have 3x raised to the power, then I have 3 minus 1, which gives me 2, then minus, I have my 5, then I bring this 2 down, then times 2x, then 2 minus 1 gives me 1. Then remember, when I have 2x, differential will just be the coefficient, which is 2. So dy over dx will be equals to 2 times 3 is what? 6x squared minus 5 times 2 is what? 10x, then plus 2. Pretty straightforward. So now let's look at this other example over here. And here we are told that y is equals to 3x squared plus 1 over x. So what I want to do first is to write this out properly so I can apply the law. So I can also write this y to be equals to what? 3x squared, and 1 over x, I can write it as x raised power minus 1. And how do I get that? You recall that this is what is resulting based on my law of indices. So now I can apply and try to differentiate each of these steps individually and try to sum them up. So dy over dx will be equals to, I'll bring down my 2. So I'm going to do it straightforward now. So I bring down my 2 here. So I have 2 times 3, which gives me 6. Then I have x. Then my power will be 2 minus 1, which gives me 1. So I don't have to write it here. So I have plus. In this case, I bring down my minus 1. So I have minus 1 times x. Then I have x raised power minus 1. Then I minus 1 from it again. So here, when I simplify everything, I have dy over dx because of what? 6x. Then minus times plus give me minus. So minus x. And minus 1 gives me minus 2. And I can write this out as 6x minus 1 over x squared. So as you can see, pretty straightforward. So let's look at some more examples. So here I told that if y is equals to this, that we should differentiate this expression. So how do we go about that? So the first thing we want to do is we want to try to simplify this expression over here. And how do we achieve that? We achieve that by applying a simple concept in mathematics that I'm going to explain now. So now let's assume I have, say, 6 plus 4 over 2. I know that this is just going to be equals to 10 over 2, which is equals to 5. Alternatively, I can like to split this out, and when I split it out, I can write this also as 6 over 2 plus 4 over 2, and that gives me what? 3 plus 2, and that gives me 5. So I'm going to apply the same idea to this expression here. So y can also be written as x cubed over x plus 2x squared over x, then plus 1 over x. And when you simplify, I have y is equals to x cubed divided by x will give me x squared, then 2x squared over x will give me 2x, and 1 over x will give me x to the power of minus 1. Now when I differentiate this, dy over dx, so I bring this down. So I have 2x raised to the power, then 2 minus 1 gives me 1, then plus, this is the form of x. When I differentiate 2x, I'm left with the coefficient alone, which is 2. And this becomes my minus 1. I bring it down here. So this becomes minus x raised to the power. Then I have minus 1, which becomes minus 2. So when I differentiate this expression, this is what I get. So now let's look at the second example where I told that y is equals to the square root of x plus 1 over square root of x minus 3. So what we want to do also is to write this out in identifiable form. So I know that x square root of x can be written as x raised to the power half. Then this is like saying 1 over x raised to the power half, then minus 3. This becomes x raised to the power half. And from our law of indices, to remove this reciprocal or to remove this reciprocal sign, I have to mark the minus to these indices. So I can also write this out as x raised to the power minus half, then I have minus 3. So now I can differentiate this. So I have my dy over dx to be equals to, my half comes down. So I have half x raised to the power half minus 1. So half minus 1 gives me minus half. Then minus half comes down there again. So I have minus half. Then I have x raised to the power minus half minus 1, which gives me minus 3 over 2. And when I differentiate 3, which is a constant, I get 0. So I can simplify this. So I have dy over dx is equals to this same thing as saying 1 over 2x raised to the power half minus 1 over 2x raised to the power 3 over 2. So you can choose to simplify it further, but I'm going to stop here for now. So you can see how we differentiate when it's a sum. So we just treat each of the terms individually and we try to differentiate it and we sum up the results. So pretty straightforward. So now we are going to be looking at the derivative of trigonometrical functions, and I should mention that for the purposes of JAMB we are only going to be looking at three functions: the sine, the cosine and the tangent. So you should try to memorize this, that when you differentiate sine x with respect to x, you get cos x. When you differentiate cos x with respect to x, you get minus sine x. And when you differentiate tan x with respect to x, you get sec squared x. And if you remember from our trigonometric ratios, sec x is the same thing as 1 over cos x. So try to keep this at the back of your mind and you should try to memorize this. So another thing I want to mention now with regard to trigonometric ratio is in the variety in which the question can come out. For instance, you can be given that if y is equals to sine theta, that you should find dy over d theta. So this is pretty straightforward. So what have we done here? We have just replaced the value of x with theta, so the same idea applies. So in this case, dy over d theta will still be equals to, you know that when I differentiate sine x, I'll get cos x. So here, when I differentiate sine theta, I'll get what? Cos theta. So my point is that it does not have to be y and x at all point in time. It can be anything. For example, you can be given that, let's say, you can be told that k is equals to cos w. We're now told to find dk over dw. So in this case, you can see that the value of y has been replaced with k and the value of x has been replaced with w. So the same logic applies. So dk over dw will be equals to what? When I differentiate cos x, I get minus sine x. So yeah, I'll get minus sine w. So as you can see, it does not have to be y and x every time, but you should know that irrespective of what it is, the same general idea that we've applied when it's x and y applies also. So you should take note of that. So that will be all for now.